agenda for today, we go into inheritance and pointers and how or why it's important to use inheritance with pointers. We talk about this concept object slicing, which is creating a base class and then creating a derived class and then assigning the derived class to the base class variable. When you do this, C++ will slice off functionality that exists in the derived class. Okay, so we'll see an example for this. Polymorphism, we'll talk about how we implement it with virtual functions and the use of the keywords override and final to help us maintain the integrity of our source code. Pure virtual functions, how they help us implement abstract class, and an abstract class with at least one pure virtual function. A class with at least one pure virtual function is an abstract class. Okay, so we'll talk about this. Okay, so let's go and let's get started. So if we have a bank account and we create an instance of savings account, right? So we have a bank account pointer, we create a savings account, and we get the balance. Oh, actually not there yet. And we say as, notice we have 4 functions. However, if we go and look at the header for savings, we see that this one's not included, meaning bank account does not know that savings account has more functionality. If we want that functionality, then we have to use the concept of cast. So we have to temporarily change this pointer of bank account to a pointer of savings account. And this right here is the code that does it. We use a special function static cast, and in here we say be a pointer of savings account, and s.get gets the pointer that the bank account is pointing to, which is savings account, and only after that can we see the get earned, right? So if I do this, notice now we can see get earned, which means now we should be able to execute this example. Okay, so that's good. What about the balance? So we say balance s get balance, and we run the program again. Let me put a new line to make it better. $500. However, we know that savings account has interest. So C++ is doing what? C++ is running this GetBalance that simply returns balance. We want this one to execute. We know we can do that by using the casting. So I'll put balance derived, meaning derived class, and then we just simply change this call to get balance, and let's run the program again. Notice now it is bringing back the interest earned. No decimals because we are using int in get balance, but that's fine. Okay, kind of like an okay workaround, but it would be better if C++ could determine what to run at runtime. So what's happening here with this sGetBalance is called static binding, meaning C++ will always default to executing the getBalance of the function for the base class. this GetBalance has been overwritten. And when that's the case, C++ will always default to running the base derived class. We don't want that. Why? Well, just imagine in the month accounting, and we are dealing with different types of bank accounts, savings account, checking accounts, and money market accounts, and other types of accounts. Then we would want to add all those to a vector, and recall a vector only works with one data type. So we have to create a pointer to unique to bank accounts as the vector element. Then we can create an instance of checking, an instance of savings, an instance of money market, and what have you. That's our goal. How do we do that? Well, if we go back and look at our notes, let me briefly just talk about the object slicing before I forget, okay? So then if we look at this, we have this and this. So bank account has one private member. Static's not stored on the stack, it's on a different memory region. We have interest and time, okay? So what does that mean? Well, let's go here and let's create a bank account, and let's say size of A1 and we run it. I can put a new line, but that's fine. So 4 and 24, okay? Bank is stored in 4 bytes. Savings in 24 bytes. What does that mean? What does that mean for us? So what that means is if we create a bank account, it's stored in 4 bytes, 1 block of memory. Savings is stored in 1, 2, 3, 4, 5, 6 4-byte blocks of memory. If we run the statement A1 equals S1, S1 is too big, it's 24 bytes. So what C++ will do is it'll only save 4 bytes, thus eliminating or slicing off parts of the object that we don't want. To prevent that from happening, what we can do is create pointers. So if we create pointers, then we should be able to do this. Once we create pointers, then instead of switching memory, what we're doing is simply switching pointers. Originally, A is pointing to 4 bytes of memory. S is pointing to 6 bytes of memory. When we say A equals S, then we are saying don't point to the 4 bytes anymore, point to the 24 bytes, and we do not have the object slicing. So that's the importance of pointers in C++. Okay, so let me now continue with what we were doing over here. What if we want C++ to default to this piece? Okay, so let me remove that code. That's where virtual functions come in, right? And that's our next topic. So virtual functions will help us tell C++, hey, virtual. Just by adding the keyword virtual, then C++ will default to dynamic binding, meaning it will wait till runtime to determine which GetBalance to execute, whether the base class or the derived class. In this case, it should default to the derived class because that's what the virtual does. And if we go back and look at this and polymorphism virtual function, so we can conclude, oh, virtual functions allow us to implement polymorphism, meaning bank balance can be a savings account or a checking account or a money market account at runtime, depending on our needs, right? So let's go ahead and run this code. Notice now balance 506 and before 500. It was defaulting to base GetBalance. Now it's using derive GetBalance, which is what we want, right? What does derive do? Balance times interest times time plus balance, right? So it includes the interest hypothetically here. Okay, so what about issues we may run into? Well, we may inadvertently add a parameter, and notice if we look at GetBalance, no parameters here, and we may think we are overriding, but we are not. So to prevent that situation from happening, we can tell C++ with this keyword overwrite, hey, look in the base class and make sure that there's an getBalance const. C++ will do that and not return an error if everything's okay. If we have an error, meaning the signature does not match this as a parameter, this one does not, then C++ will tell us that we are not overriding a base class member function. Okay, so good. And that's override. Let's jump over to a checking account and we'll just create something silly here. We'll also say I want to overwrite GetBalanced, and I'll simply say that I want to return balance plus 10, just so that we can know that something's different, right? We do that and notice everything's okay. We come back here, let's build. Everything is okay. We go into main. Let me remove this. I have a savings account. I guess that's okay. And let me now create another pointer to bank account, unique pointer to bank account, checking, make unique, checking account, 100. Now let me create a vector using vector. So I'll create a vector of unique pointer to bank account because I want to store different instances of bank account in my vector. Okay, so I have this. Name it accounts, that creates an empty vector. I can say accounts.pushback. Use that special move function. S at the savings and now the checkings. Afterwards, I want to iterate the vector. So for account in accounts, see out the balance. And I run this. And notice C++ is able to work with them. And that's what we are shooting for with polymorphism, where we can create a list of pointer to something, and then we simply add the derived class instances, and C++ via polymorphism can execute the correct function, right? So we are looking at the power of object-oriented programming and polymorphism. And again, polymorphism stands for take many forms. I think its origin is Greek, So we can see that the bank account is a checking, is a savings, depending on what instance the pointer is pointing to, okay? Okay, so now we jump back here. We talked about the override keyword, and now let's think about deposit and withdraw. No matter which bank you go to in the world, when you deposit money, say you deposit 25, whatever, $25, yen, whatever, you will get credit for only that amount, not more, not less. The same thing for withdraw. You withdraw 25, you will be deducted or debited 25, no more, no less. Even if there's a promotion going on where you deposit an X amount of money and then you get a bonus, that deposit will be, say, for example, 10,000, and say the bonus is 250, but only if you keep the money in there for 3 months. Well, you only get credit for 10,000. Later on, after 3 months, you'll get 250. Okay, so that's an important distinction to make here. So what am I trying to say? These two functions will never change. So we don't want them to be touched by the derived classes. We don't want checking account or savings account or other classes to modify it. And we can do that by making them virtual and using the keyword final. Once we do this, then we are locking them down. They're final. No one can ever try to modify them. And if we try to modify them, the compiler will not even let us compile our code. So here, notice, and it's telling me cannot override final bank account deposit. It's because we've marked it final. So why do we do this? Remember, with object-oriented programming, we are trying to model the real world. Thus, we do that by locking deposit and withdraw down. They will never change no matter what. In essence, we are modeling the real world, okay? Okay, so let's go here. Let's talk about an abstract class. So the concept of an abstract class can be demonstrated with a shape. So if we have a shape, and I point, I don't say, look at that shape over there. I say, hey, look at that doorknob, look at that tennis shoe, look at that wall, look at that picture on the wall. We always describe a concrete shape. So then what is shape? Shape is an abstract concept. And if we focus or limit our focus of shapes to, say, graphics, then we can say, well, shape can be a line, it can be a square, or it can be maybe like text, right? And now if I say, look at the line, you more than likely know what I'm talking about. If I say, look at the square or text, then you know what I'm talking about. So these are concrete or real objects, okay? So how do we link this to programming? Well, we can say that the shape is the base class or the superclass or the parent class. And then the concrete classes can be the base class, not the base class, the derived class, subclass, or child class. And they will realize a concept of shape, meaning they will make it real. How? Well, we can have, say, a function draw that knows how to draw itself onto, say, a screen, right? So we know that they inherit, line, square, and text inherit from shape, but we need something. We need a contract. We need a contract that forces derived classes to provide code or functionality to the draw function, right? Meaning if I'm line or square root text and I want to inherit from shape, then I better provide code for draw in my class. If I do not, then I myself become an abstract class, and I don't want to. Also, it's important to understand that shape does not have to provide any functionality for draw. It can if it needs to, but in this case it does not. So how do we force this contract? Well, with the concept of pure virtual functions. And a class with one pure virtual function is an abstract class. And an abstract class can't be created. An instance can't be created. Why? Well, because it's an abstract concept. Okay, like shape is an abstract concept, so we can't create it. The only way we'll create a shape instance is if we create derive from line, from shape, create an instance of line, then behind the scenes a shape is created. That's the only way we should be able to do this, okay? So how do we do this in code? Okay, let's write this code first, okay? So let's go here. We got shape, and let's go to the shape. Again, do not forget, if not defined, shape header, define it, and if class shape, semicolon, void draw, we need to make this a pure virtual function, so we say virtual and we set it equal to 0. This makes it a pure virtual function, and then this makes this class an abstract class because it has at least one pure virtual function. Okay. Now, if I can spell this correctly. Okay. And notice I do not have to provide code for draw in shape, because how are we going to draw a shape? So we don't provide code for it. Now we can derive from it. Let me include IOStream here. And now I can go to line, if not defined, line header, define line header, and if class line inherits from shape, semicolon. Let me show you what happens if we do not implement line, okay? let me close this and let me go to main here. So then if I say line, trying to create an instance of line, notice that it thinks that line is an abstract class. And it's like I told you, if we do not provide functionality for draw in line, then line becomes an abstract class. We don't want that in this case. We want to provide the functionality. So we're like, okay, void draw overwrite. And let's write some code in the CPP for this one. I have to first make sure that I remember to include shape, include line, make draw part of line, using cout. Notice I include IOStream here, I include shape here, so implicitly I'm including cout. That's why I can do using instead cout. I come here, I'm like cout, and I'll just say line, okay? And I've implemented this part. Okay, I have square, but it's circle. Okay, so we'll do circle. If not defined circle header, define circle header. And if class circle inherit from shape, override draw, provide the code in the CPP, circle, meaning make it part of the circle class, it being draw. Again, implicitly I'm adding cout by including shape in the header for circle. Then I can simply say using cout, and here I can say circle. Okay, so let me go here. I didn't include shape, so then I can say shape. Okay, and if I go back to circle, then this should be okay now. See, it's okay. So I've created the hierarchy. I go to main, create a shape pointer of type line, create vector of shape pointers. Okay, so meaning I need to include vector, using vector, include memory, using unique pointer, using make unique. Now I can come here, create a vector unique pointer to shape, name it shapes, create a unique pointer to shape, name it line, make unique an instance of line, do the same thing, shape circle, make unique instance of circle, add to the vector pushback, use the special move function, line, circle, iterate the vector. You need the reference here, okay? For each shape in shapes, not see out, shape, draw. Execute this code, run, and notice line and circle. So we've implemented the concept of polymorphism. We've used abstract classes with pure virtual functions to make abstract class, meaning we cannot create an instance of shape. We can try. I can say shape is. It won't let me. Abstract class is not allowed. Okay, so we create the derived class and then shape on the left side, and we're okay. Okay, so we jump now to our bank account example. Here. And if you think about it, bank account should be an abstract class too, because when you go to the bank, you either take money out from savings or checking or some other thing, right? So we need to make this abstract. So we come back into our source code and we go to the header for a bank account, and then we have to move the return statement as a CPP function implementation. Okay, so I did that already. And then we say equals 0, thus making this a pure virtual function, thus making bank account an abstract class. Once we do that, then we should not be able to create instances of bank account. So if I go here and I want to create an instance of a bank account, it won't let me. Notice abstract class. I remove this, it's not an abstract class anymore. Notice it lets me create the instance, okay? But in this case, we do want that. We want to make it a pure virtual function, thus an abstract class, so we cannot create instances of bank account. This all still works because we are creating a pointer of bank account, instance of savings, instance of checking. And I've already changed the code for the test case. Notice I create a pointer to bank account on the right side, a savings account or a checking account. And also do not forget that instead of dot, you use the arrow operator for your code, okay? So I also had to modify some code in the bank account. I had to remove this and I had to remove this because I can't work with instances of bank account, okay? But we will fix that in the near future, okay? So I do apologize. I forgot to, I guess I mistakenly pressed pause yesterday on the lecture, so then I had to re-record this. So that's why there's no student interaction. So I do apologize for that. Okay, thanks.